Hello, everyone. I just want to walk you through getting introduced to the protein purification simulation module. Okay, so if you're working on the internet on your computer, you can come right here to agbooth.com/pp_web. Alternately, if you'd like to work on your phone, there are links over here. This app is available for the iPhone where I've tested it. I've not tested it on Kindle or Android, but everything seems to be pretty good cross-platform. So if you prefer to run it on a tablet or something, feel free. I found it a little small with my phone, so I'm doing most of my work on my computer, but you're welcome to make a different choice. It does run right in the web browser, so you don't need to install anything. Although if you scroll down on this page, you will see some options to download and install. It's unnecessary. The one in the web browser should work just fine. Okay, so here we come. In this version of the app, we're going to be asked to choose a mixture to purify. So I'll go ahead and do that. I'll choose the example mixture, and then it's going to ask which protein we want. So as you're following along in the directions, you'll choose whichever protein I've told you to from whichever mixture, and then click OK. The OK button hangs up in here in the top right corner. For some reason, I seem to have trouble finding it, so you may do better than I do. When you pick which protein you want, you get information about your protein in terms of its temperature stability and in terms of its pH stability. This information does not display anywhere else, so please write it down. You will probably want it. So we'll click Purify to start. And then here we get this purification table. It reminds us which protein we're working with in case we've forgotten. Okay, and then as we do purification steps, it's going to write down for us and record the various steps. There are a couple of important numbers here to look at. We have how many milligrams of protein we're starting with, and it varies from sample to sample, so don't be surprised if yours looks different from mine. Okay, but that's total protein. This is going to be a crude mixture of multiple proteins. Example mixture has 6. Some of the other ones have 30. Okay, that's all the protein that's present, not just the target protein. And then over here we have units of our enzyme. This number tells us about specifically how much enzyme is present. Our goal is to keep this amount of enzyme pretty close to the starting amount, but we expect that we're going to be reducing our total protein amount because we are losing protein impurities as we do the work, okay? Enrichment tells us how many times better it is than the starting condition, and yield tells us how much of our enzyme we've hung on to. Finally, there's some information over here about cost and time. For some of the later exercises, we may try to figure out what's a fast, cheap way to get to the result, because sometimes we don't want to do the most expensive of the various options. We just want to get there at a pretty good speed with pretty good yield and purity. Okay, so once you've gotten to this screen and you've chosen your protein, then you have a whole range of different methods that could be used, possibly, to purify your protein. We'll come back to those in just a second. I want to look at the gels first. It's labeled electrophoresis, but we're talking about protein gels. Okay. You can have a one-dimensional page. That's a polyacrylamide gel. Okay. And MR here is the molecular weight. This is kind of like what we did with the plasmids. Our scale now is in kilodaltons or kilo AMUs for thinking about what one molecule of our protein weighs. Okay, but this is our ladder. And then our second lane over here is showing us what our initial mixture looks like. So although the introductory material told us we had 6 proteins, we're only pretty clearly seeing 4. So we might want to get suspicious right up front that there are probably several proteins in some of these bands. Okay, we're going to go over to two-dimensional page gel. And in our two-dimensional page gel, we again are only seeing 4 bands. So we must have some proteins that are really similar. There's a great video in the exercise that you'll get to a little later that talks about how these things are run. But the short answer is you get information about your protein's PI and its molecular weight. So since we're separating based on two properties here, we can get more information, and we can sometimes take two proteins that might be the same in terms of size and get different results here. Okay, well, how do I know which of these is my protein? Right now, we are staining with Kumasi blue, but we have another option, which is immunoblot. For immunoblotting, we're using an antibody to specifically identify just our protein. Kumasi blue shows all the proteins in the mixture. Immunoblotting shows just our protein. So it says it's using an antibody to protein 4. So now we know that this band here corresponds to our target protein. Our goal is to get this guy, okay? So that's how we do our gels. You can also, in 1D gels, use immunoblotting and find out which of your bands in the 1D gel is the target protein as well. When you're tired of looking at gels, go back to record. We haven't purified the protein yet. We've just done some analysis on what we're doing, okay? I want to sort of walk you through a little bit. What does it look like if you do some chromatography? So I'm going to pick gel filtration chromatography, and we'll just pick some defaults. By the way, down here, this button, when it shows up, is extra information. There's a big pop-up with lots of great stuff. You could read it. You should read it. You'll learn useful stuff. But to actually do what you've selected, the OK button is up here. I'm several hours in and I'm still clicking the wrong button, so bear with me. All right, so we'll click OK. And now what are we seeing? We're looking at absorbance at 280. That's measuring the amount of protein, and it's measuring all proteins. Proteins absorb pretty strongly at 280, okay? And then on this x-axis, we're looking at the fraction number. So what's going on here is we have a column, and that column is going drip, 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 and we're catching a small number of drips in each of these fractions. So we'd be swapping in test tubes to catch each of the fractions coming off the column, okay? So we can actually see here 1, 2, 3, 4, 5, 6 separate proteins. But how do we know which protein is ours? Well, there is this very handy button here that says Assay Enzyme Activity. Let's click it. What we do when we have a bunch of fractions and we don't know where our protein is, it's not enough to look at the absorbance. That just tells us there's some protein. Is if we have an enzyme assay that we can do, if we can look at the reactivity of the enzyme, we can figure out which fractions have my enzyme. And so this red curve represents where is my enzyme activity. So now I know that it's this portion of the sample, this peak, is my enzyme. It's protein 4. And so those other 5 must be the other 5 proteins in the mix. Okay, great. So we found it. You can also, if you're interested, choose to run a gel. So if I wanted to see what that fraction looked like, I could pick out this fraction or any other fraction and hit the button to, not that button, and hit the OK button to see the gel of just that peak. That would be a good way for me to confirm, yeah, that really is my protein. You could also believe the activity assay, the enzyme activity assay. It's trustworthy. Okay, once you've decided where your protein is, whether you've done it with enzyme activity or you've done it by running a gel on each of your individual peaks separately, then you need to put your fractions together. We want to decide which part of our sample we want to keep and which part we're going to throw out. So I'm going to change my fractions so that I'm collecting the peak that has the enzyme activity and leaving the rest of those proteins behind. Often it's helpful to be sort of stingy on how many fractions you take. It can be a trade-off between the purity and the yield. So you may need to play with it a little bit. Okay. Once we hit OK, after pool fractions, we are committing to keeping just this sample. So make pretty sure you're happy with it before you go on. If you've realized you don't want to pool fractions yet, this back arrow will back you up. All right, so I like those fractions. I'm going to hit OK, and it's going to tell me what happened. We'll see our total protein has gone down. Our total enzyme has gone down, but not very much, and our enrichment is a lot better. Let's look at that in the table. So after gel filtration, total protein went down, but look, enzyme hardly budged. So we threw away all the protein in those other peaks, and we kept our target enzyme. We kept almost all of it. That's a great result. Okay. Is our protein pure now? Let's take a look. By 2D page, we have a single band here, and immunoblotting confirms for us that yes, that's our protein. So we did great. We can go back to record to write this one up. If we were doing this one for part of the lab report, you'd want to get a screenshot of this result. And I also often ask you to get a screenshot of the 2D page showing that you removed the other unwanted proteins. Let me point out real quick here that the details here are not shown. It just says gel filtration. You would need to tell me which kind of gel filtration did you do, which fractions did you take. All of that needs to go in your report. So watch out. We're not really keeping a lab notebook in the traditional sense for this exercise, but you do need to write down what you're doing, or else when it gets to be lab report time, you're going to have to do it all again. Don't go there. Okay, two other things to point out to you. If you get partway through this and you're like, I need a break, because sometimes you're not pure after one step and you might need to do some more steps, or you're worried that you may in the next step totally ruin it, there's a button here for store your material. It produces this great big mess. You can copy and paste it all and save it into a file and then load it back in later. So in the web app, it doesn't directly save for you, but if you save this, you can load it later, okay? If you're on the phone, it'll actually prompt you instead to enter a name for your sample, and it will actually save it for you. So that's an advantage of the phone. I like a bigger screen myself, okay? You could also decide that you have messed up and need a restart. I've done a lot of that this week. So in that case, you would say abandon scheme and start again. And then do we really want to do this? It's giving us a chance to say, whoa, whoa, no, not yet. If you do, you click yes, and it'll take you back to the first screen and you could start again. If you did store material, this import a mixture button would allow you to paste in the information that you had saved from before. Okay, so that would be a way to recover your work. I hope that's helpful. We're going to tackle a lot of really interesting ones in the next couple of weeks, and holler at me if you get stumped. Have a great one.